In this question, we're going to try to find the integral of the floor function of x squared between 0 and 3. The key idea to solve this problem is to apply the definition of the floor function where it's defined. We need to split this interval, which is 0, 3, accordingly based on these values of x squared. How can we do that? The key in this case is to note that if we let the floor function of x squared equal k, then this means that x squared is between k and k plus 1. All these values are positive, and therefore, when we take the square root, we get x is between the square root of k and k plus 1. Okay? In our case, x is in this interval, 0, 3. And hence, the square root of k is going to be between 0 and 3, and therefore k is going to be between 0 and 9. Okay? We have to treat all these cases. Okay? Therefore, we're going to divide this interval according to the values of k. Okay? And we can do this by just looking at the interval. 0, 3 can be divided in the following manner. Okay? Because the values of k can be between 0 and 9, and given that x is between the square root of k and the square root of k plus 1, we see that we can write 0, 3, the interval, as 0, 1, union 1 square root of 2, union square root of 2, square root of 3, and etc. until we get to square root of 8, square root of 9, which is 3. And each on these intervals, the value of the floor of x squared change. Okay? Therefore, if x is in this interval, 0, 1, then f of x is 0. If x is between 1 and the square root of 2, the floor function is 1. If x is between the square root of 2 and the square root of 3, the floor function is 2. Remember, the floor function in this case is just 2 because x is between square root of 2, square root of 3, and therefore x squared is between this one and this one. Okay? Now, if x is between the square root of 3 and the square root of 4, square root of 2, or square root of 4, which is 2, I have f of x is 3. Now, if x is between 2 and the square root of 5, f of x is going to be x squared, which is 4 in this case. And if x is between the square root of 5, the square root of 6, f of x is going to be 5. If x is between the square root of 6 and the square root of 7, f of x is 6. If x is between the square root of 7 and the square root of 8, f of x is 7. And finally, if x is between the square root of 8 and the square root of 9, which is 3, f of x is 8. Okay? Note that these ones are not included here. Okay? Okay? It's my handwriting, so it's not included. Okay? Therefore, the integral is going to be the sum of these. Let's draw it. Okay? Let's make a small, not to scale. Okay? Let's make a small drawing of these values here. So I'm going to assume 0, 1. I'm going to assume that this is the square root of 2. This is the square root of 3. This is the square root of 5. The square root of 6. 5, 6, 7, 8, and 3. This is not drawn to scale. It's just to explain. Here between 0 and 1, the floor value is 0. Here it's 1, here it's 2, 3, and until the last one, which is 8. Okay? It's this one here, between this last 2. This is 7. And therefore, the integral is just the sum of these areas, these rectangles. Okay? This one is 0. Okay? And this one. Clearly, you see, you get the idea. So this is my area. This is my integral here. This is the areas, the sum of these areas. How can I do this? How can I sum this one up? So I'm gonna sum everything using these values here. For instance, between the square root of 6, 1x is between the square root of 6 and the square root of 7, not included. I have the area here is this width, which is square root of 7 minus square root of 6 times 6. So this is the area here, this area here. This is its value. If I add, I'm going to obtain 0 plus 1 times the square root of 2 minus 1 plus 2 square root of 3 minus square root of 2 plus 3 this 2 minus square root of 3 plus 4 the square root of 5 minus 2 plus 6 the square root of 7 minus square root of 6 plus 7 the square root of 8 minus square root of 7 plus 8, 3 minus square root of 8. Okay, if I add all this, I got this last number here, which is bigger, because I'm expecting this one to be positive. Let's first simplify this one. I got 0 plus square root of 2 minus 2 square root of 2. It's minus square root of 2, and 2 square root of 3 minus 3 square root of 3 minus square root of 3, and I keep getting this one. Let's write the square root of 4 for clarification. Minus square root of 5 minus square root of 6 minus square root of 7 minus square root of 8 plus the last one, which is 24. I missed minus 1. Where did minus 1 go? It's minus plus 0 minus 1. Let's see, minus 1 minus. Okay? Let's say for 8 I get 7 square root of 8 minus 8 square root of 8. That's minus square root of 8. Therefore, I get 24 minus 1 plus square root of 2 plus square root of 3 plus square root of 4 plus square root of 5 plus square root of 6 plus square root of 7 plus square root of 8. And this is my area. And I'm expecting this one to be positive. Okay? What's this sum here? 1 plus square root of 2 plus square root of 3 plus square root of 4 plus square root of 5 plus what's this area here? Okay? And this one is bigger. Therefore, I can use my calculator and check it, but you can do so. So the value of this one here is this value here. I don't want to write it again. So if you see any mistakes, please correct them. Comment, share, and subscribe. And this is how you deal with this floor function integration. You treat them case by case. Okay, thank you very much.